Hello, ladies and gentlemen, and welcome to what should be a quick and easy lesson on multiplying by factors of 10. But more importantly, hopefully, I can help you understand why this is so important and why it helps you to solve multi digit numbers, such as 2 digit numbers and 3 digit numbers, with multiplication much faster than using a simple standard algorithm. So let's get started. Hopefully already you understand how to do basic multiplication with single digit numbers such as 24 times 3. And what you have learned there is to simply take that bottom number and multiply it by both of the top numbers or both of the place values up top. So this 3 times the ones place and 3 times the tens place, where 3 times 4 would be 12. And much like in addition, we remember that the bottom number, if we're given a double digit product, such as 3 times 4 is 12, the ones place is going to come down, and we're going to move that tens place up and over to our next column for our next step. So the 12, our 2 is going to come down here, our 1 is going to come up and over, and then when we multiply 3 times 2, there was something you should have learned prior to this, and that is to add anything that is up top, not multiply it, but you add that to the product of whatever you get when you multiplied those two numbers. So 3 times 2 is 6, plus 1 is 7, and therefore 24 times 3 is 72. All right, that was just some brief history on single digit multiplication. What I want to focus on is situations where we're given 24 times 10. And in this case, we are going to start with the ones place just like you have before, and we're going to multiply that ones place by the 4, and then we're going to multiply that ones place by the 2. When you do that, 0 times 4 is 0, and 0 times 2 is also 0. And that can seem rather confusing, but hopefully by the time we're done with this video, we'll understand why this works this way, and I'll also help you create some math shortcuts, if you will, if you'll just follow along. So we still have that 24 times 1 over here, or the tens place, 1 times 4. When we're using double-digit division, and I'll do another video on this, when you're doing multi-digit division, we need to make sure that since we finished with our ones place and we've moved on to our tens place, that we're going to go ahead and put a 0 right here for that tens place. So that we're multiplying just by 1. And then 1 times 4 is 4, and 1 times 2 is 2. Confused yet? That's okay. We're going to get you there. 0 plus 0 is 0, 0 plus 4 is 4, 2 plus nothing is 2, and there we go. 24 times 10 comes out to be 240. But for many of our 5th grade learners, this can be a very difficult process and a very confusing process because of all the zeros and all the steps. So I want to focus on exactly what the 10 does for us. Most of our students already know by 5th grade counting by tens, and that is that 10 times 1 equals 10, 10 times 2 equals 20, 10 times 3 is 30, 10 times 4 is 40, 5 is 50, and they've been counting by 10 since probably first grade, second grade, some of them even kindergarten. And hopefully they've been able to notice by now that there is a pattern, and that is when you multiply by 10, really all that's happening is that you're adding a 0 at the end of each number. We multiply by 2, there's a 0 at the end. We multiply by 3, there's a 0 at the end. Multiply by 4, there's a 0 at the end. And this will actually happen all the way until you get into your double digits, such as 12. 10 times 12 is 120. Again, look, we still have our base 12, and all we did is move that 0 over to the end. Just like up here, when we had 10 times 6, the 6 stayed the same. The 0 basically had just been brought over. But the reason why multiplying by factors of 10, that is not just 10, but any number that ends in 0, kind of has to follow the same rule. And I'll use a simple one to kind of help you see that. We'll just do 20. 20 times 1 is 20. 20 times 2 is 40. 20 times 3 is 60. Times 4, 80. 20 times 5 would be 100. 20 times 6 would be 120. And even if we were to go into 20 times 10, we would get that was 200. And if you're not able to see the pattern here, that's okay. I'm going to help you to use a more standard algorithm to see this picture. But all that's happening here again is we just have that 0 because our number, our first factor that we were starting with ended in 0. All of our answers end in 0. And just like before, with that first, with our example of 10, we just multiplied, with the 12, we just had that by itself. Here, what's happening is we're just taking that 2 that's left over from the 20 and multiplying it by the other factor. So since that 0 had already been brought over, we have 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. Again, we just added the 0 because of the 0 at the end of 20. 2 times 6 is 12. So we're still following that same pattern. Let's see what that looks like with the standard algorithm. I'm going to do, let's see, 34 times 20. And what we're going to end up doing, or what we're going to see, just like we saw before, is that 34 is just going to be multiplied by that 2, and we're going to have a 0 at the end. I'm going to check our work for when we're done. 34 times 2, for those who don't know, 2 times 4 is 8, and 2 times 3 is 6. So what we should get over here is a 680 because there is a 0 at the end. Again, our number was 20. I kind of just left it off to show you an example here. But what's going to be happening here is that we're still going to end up with 680 using our standard algorithm. So 0 times 4 is 0. 0 times 3 is 0. We're done using that 0. And then we're going to do our 2 from the tens place. 2, oh wait, since we're starting with our tens place, we have to start with another 0. You'd be surprised how many students struggle with remembering to put that 0 in the tens place. And that's why this video is designed the way that it is. I'm going to show you here right after this exactly how much faster we can do this by eliminating a single step. Anyway, back to work. 2 times 4 is going to be 8, and 2 times 3 is 6. We add those two partial products together, lo and behold, just like I told you we should get, we got 680. So this will work with any number that ends in 0. And what I mean this will work is that we can go ahead and eliminate this first step of all these zeros. To help our students out, we're going to teach them to move any numbers that end, or a product, or excuse me, a factor that ends in 0. We're going to teach them to scoot it over to the right, just like this, so that we can bring down that 0 and only have to do a single step in our multiplication. Let me show you what I mean. We're going to go ahead this time and do 42 times 30. But this time, I'm going to write it with that 0 off to the right. Okay? I'm not exactly lining up my place values like your students are used to. That 0 is clearly off by itself, kind of leaning off the edge. It's not lined up with anything. Because as we saw up here with our example, that led from these examples, that 0 can just be brought down. We've learned that any number that's multiplied by a factor of 10, whether it be 10, 20, or 30, or anything else, it's going to end in 0. So I'm just going to bring that 0 down. Now that I've brought that 0 down, I don't need to do anything else with it. And what I've done for my students is help them to do a simple 4th grade or 3rd grade level problem where they're multiplying just a single digit by a multi-digit number up top. So now 3 times 2 is 6. 3 times 4 is going to be 12. We can write it there since it's our last step. And we see that 42 times 30 is 1,260. And what we're going to find is that this will actually work even with larger numbers, such as the hundreds place. We'll do it something simple, 17 times 600. We can write both of those zeros off to the side since both end in 0. That allows us to bring both of those zeros down. We don't have to do anything with them. We've eliminated that step. And now this big scary problem of multiplying by a 3-digit number has become very, very simple because all we have is a simple 3rd or 4th grade problem with a single-digit number. Here, 6 times 7 is 42, so the 2 is going to come down, the 4 is going to come up. Remember, anything that we bring up top when we carry in multiplication is actually going to be added to the next column after we do our multiplication. So 6 times 1 is 6, plus 4 is 10. 1, 2, 3, comma. So 17 times 600 is 10,200. One last note before I let you go, and I'm going to do a video on this strategy entirely, which is why I'm only going to do one example. But here's exactly why I believe this is so important and why it helps, and how I'm going to teach your student to use this on a regular basis to help them get through their math problems much faster and with less anxiety. Consider the problem 327 times 43. The strategy I'm going to teach them is called decomposition, and it just takes advantage of what's known as the distributive property of multiplication. That being that what we are doing is distributing or passing out each of these digits or place values one at a time. But the way I'm going to do that, and I'm going to write this a different way to help you see this a little bit better, we're doing 327 times 43. Okay? And the law of the distribution states as long as we take everything from one column in multiplication or in one set of parentheses and multiply it by everything in the other set of parentheses, we're going to get the same answer or the same product. So what we're going to do in this strategy is actually break apart one of the numbers. And we could actually break apart both if we really wanted to, and we'll get to that at some point. And when I say break apart, I mean to decompose them by place value. 43 is the same as 40 plus 3. Well, here is where that 0 comes in handy, and knowing that special trick to be able to break these numbers up. What we're saying is that, same as before, as long as we take everything from this first parentheses and multiply it by everything in the second set of parentheses, we're still going to get the same answer as we did before up above. So in other words, 327 times 43 is the same as 327 times 40, there goes that 0, plus the product or answer to 327 times 3. Okay, so again, what we can do is just bring down that 0 where the kids don't have to mess with it at all. And what we've done is turn this big scary looking problem of 327 times 43 into two very simple 1-digit 3rd or 4th grade level problems. All right, so I hope what you can take away from this is being able to use factors of 10 or numbers that end in 0 and moving them off to the right, again, making something like 27 times 30 into 27 times 30 with that 0 off to the side, and bring that 0 down so you don't have to mess with it. And most of our 5th graders will agree, a problem such as this looks much less intimidating than having to look at all these numbers here and remember 5 or 6 different steps. I hope this helped. Look forward to future videos about this factor of 10 and decomposition. Have a great day.